Hello, everyone. I am Stephen Marchessault, the Customer Success Specialist here at VETRO FiberMap. Thank you for making the time to join us today for our 5th User Enablement webinar. Very glad to be here with you all again. Today we will be talking about equipment, materials, and the bill of materials in VETRO FiberMap. Joining us again is Alex Cavanero, VETRO GIS Analyst Wizard, Data Format, Customer Support Extraordinaire. And he will be taking us through a demo of the material assignments and bill of materials during the second half of the presentation. Now, before we jump into the main demo, a couple of webinar-related and other housekeeping announcements and reminders. First, of course, feel free to use the Q&A functionality of the Zoom webinar software to submit your questions. We have some VETRO panelists standing by to answer these questions for you. And if you don't receive a reply straight away, we may set your question aside until the end as a talking point, or we'll get back in touch with you with an answer to that question. So today's webinar will be recorded. All attendees will receive an email later today with a link to view or download the recording, and we'll be interleaving the slides with the demo as we go along. Just a review of our last 4 webinars. So far, we've covered some good stuff. If you haven't had the chance to go through those webinars, we highly recommend it. It's a good way to get started and get in depth on some of these topics. So these are available if you want to contact us, support@vetrofibermap.com. The recordings are also available. There are links in the product help documentation menu in the webinar section. So today we'll be talking about equipment and materials in VETRO FiberMap. Our mission, as always, is to help our customers gain the time and productivity they need to expand fiber optic broadband service. One of the main challenges faced by fiber optic cable management is, of course, strands within cables, but also the other challenge that has emerged is one of equipment within equipment and capturing costing for cables and equipment. In VETRO, we represent equipment as attachments to network points. The network points themselves can be equipment. It can get confusing, so we're going to sort this all out today and help you get oriented with how to model your network points and your equipment in VETRO FiberMap. So first, a review from some of our previous sessions. We want to just remind you what we consider to be network features. This is the main set of tools that we use in VETRO FiberMap. These are the network points and the fiber cables. These are what we use to create splicing and circuits. So just hitting on that point. And then a review on non-network features that we have available in the platform. So this includes what we consider to be the supporting cast. These are the infrastructure and utility points that are not involved in splicing and circuits. But we'll touch on this a little bit today. Some of these points and line types can accommodate hardware attachments, like in the case of poles. You can attach hardware to poles, and then you can attach material templates to these items, which will then be represented in the bill of materials. And so we'll be getting into that workflow today. So looking ahead a little bit to the section that Alex will be talking about, we'll be talking about the workflow for the material manager, material templates, and everything that gives rise to the bill of materials. But first, I want to just focus on this first section. So what we're talking about today is network points that are attached, that have equipment attached to them. So this is a very important understanding to have, that at the primary level you have network points, and then the equipment will attach to that. Within the category of network points, there are some obvious characters there. We have the CO or the POP or the head end, service locations, cabinets, things like that. But then there are certain categories that we see, or certain items that we see in both categories. So for example, a splice closure can be a network point or a piece of equipment. So there are some subtle differences between that, how it's represented, how that's configured, and we'll get into some of the reasoning for why we created it that way. So jumping right in, just to kind of review some of the things we'll be talking about in the demo. So we're going to go over the attachment of equipment to network points. So something that comes up a lot is when you're creating network points, you might want to stack a CO with a splice closure with an FAT all in one location. And we have a validation for the build that's in place that will actually flag that as a fail. So within a plan, it's important that you create one network point per single geolocation. So once you have that network point established, you can then attach single or multiple equipment connections. And the way you do that within the attributes for that point, when you're editing the point, is that plus icon, which I don't know if you can see that here where it says add new equipment, and that's contained within the attributes. So we'll show you that in the demo as well. Once you have those equipment attachments established, the way that you manage splicing to your equipment, there are a couple of different ways to manage the splicing. First is through the splice diagram. So in the splice diagram, if you're familiar in the other sessions where we've gone over how to click and drag to splice, to shift and click, to select multiple, to select entire buffers at a time, a lot of those same functionality, those methods with the mouse will apply. So you can click and drag into the output of a splitter. You can right click on a cut upstream strand to establish your input in the first place to the splitter. You can multi-select and right-click to attach multiple patch panel ports, splice closures, and then the next place that we will represent these connections is in the Show Equipment Connections menu. So when you create multiple connections in the Show Equipment Connections menu, those will be represented in the splice diagram as a bow tie icon. And it's important to note that that bow tie cannot be cut or altered from here. It signifies that you'll need to work within the Show Equipment Connections because of the complexity of multiple equipment connections and fiber connections. It necessitates that. So this is where we represent this information. So this is also in the attributes for a network point. It's the Show Equipment Connections menu. So the first thing that you need to do when you are looking at this menu is to establish incoming upstream input fibers on the left-hand side. And that's very obvious in the case of a splitter, but in one-to-one scenarios like a patch panel or a splice closure, think of it as input on the left, output on the right. And then you just click to connect fiber strands to other equipment. Or in the case of this example here, you can see we have nested a splitter out of port 4. And we'll definitely get into what that looks like. So here are some of the equipment types that we have in VETRO. Splitters and patch panels are used quite a bit. Splice closures and multiports as well. And those two categories are also able to be network points, and we'll talk about that in a moment. We also have terminal equipment at your service locations. So that can be an FTP or an ONT. And just like with anything that we have represented as a network point or a piece of equipment in VETRO, we can do custom modeling, which would be a variation on the themes that are already in place, like one-to-many with the connections, one-to-one, the number of ports, the naming, that sort of a thing. So we have modeled custom equipment in certain scenarios. So just wanted to point out that that is an option. So jumping into some of the nitty-gritty of some of these equipment types. So splitters represent a one-to-many connection. You can attach them to a CO, a service location, or any midspan point. They can also be cascaded or nested. Splitters are also used, and this is very important, if at any point you intend to backfeed a fiber pathway. And so we'll also do a demonstration of that. But the backfed strand goes to the output port of the splitter. So first you establish the upstream to the input, and then the downstream is the output. And then the final step will be to use FiberManager to establish waypoints, because FiberManager will find the quickest path from A to Z, but then if you click again to add waypoints, it will follow additional pathways. And we will also talk about that. And then we want to look at how splitters appear in reports, like circuit reports, how they're represented in the trace schematic, and then how we represent splitters in the splice report. We put a lot of time and consideration into the easiest way to represent this information in that splice report to make it very intuitive and comprehensive. So jumping into what patch panels look like. Patch panels represent a one-to-one fiber path. They can also exist in a CO, a service location, or at any midspan, and they can also be cascaded or nested. And these will be configured in the splice diagram or the Show Equipment Connections menu. We'll be showing you that. So splice closures, talking about this example with splice closures, they can be network points or they can be equipment. So in the case of a network point, we know that there is a single entity at times that is just the splice closure itself. There's no other equipment contained within, and you want to create one-to-one connections like you would see in one of these aerial splice closure examples that I have in the top right. At other times, you might have a splice closure that exists within a larger piece of equipment, like a cabinet. And so we have made it possible to add splice closures to network points like a cabinet. So then you could have a splice closure, a splitter, and so on, all contained within that cabinet. So there's some flexibility there in the modeling and how to create that, how to set that up in VETRO. Multiports can also be network points or equipment attachments. So when they are network points, it's necessary to have a pigtail strand with a matching fiber count that matches the number of ports on the multiport to create that one-to-one connection. And then when you attach multiports directly to a piece of equipment, then they can be used for these one-to-one connections, similar to what we would see with a patch panel. We have terminal equipment at service locations like the FTPs and the ONTs. They can be created manually, or they can be created using Quick Connect, all of which we'll cover. So with that, I'm going to jump into a demonstration of network points and equipment. So bear with me while I switch my screen over here and just do some resizing. Sorry for the delay. Here we are. Great. And we're back with view of VETRO FiberMap. Great. So if you've seen some of the past webinars, we've been talking about this fictional network here in Walcott, Iowa, that we've begun to build and to show off some of the features like splicing and Fiber Manager and circuits and how to create those. So we've established a second plan to the west of that fictional build. And this is my phase 2 plan over here. So I have a couple of things already in place. I have a CO with a backbone that is running down to this FAT. And so we're going to look at how to model some cabinets that are going to connect via laterals to these service locations. I just got some feedback that the audio might be a little low, so I'm going to speak up. So we're going to model here how we would split some fiber pathways out to some cabinets. I'm going to set up a cabinet that has a patch panel that is downstream of a splitter, and then bring our service locations into that. And then we'll just go through some of the various methods for all of these different equipment types and in setting them up. So one of the first things I want to do, I have editing mode enabled. So I'm going to draw a couple of cabinets. So I've selected my cabinet point type, and here is how we connect equipment, this plus icon here. So this cabinet, I want to see a patch panel, and we'll make that a 4-port patch panel, and we're going to attach a splitter, and we'll make this splitter 1x4. And so now I've gone through and added these equipment attachments, and I can fill out any attributes. And rather than clicking to draw and then saving and doing it all over again, I can use autosave VETRO parts with the same attributes to draw multiple instances if I have, you know, a cabinet that has all of the same attributes. So I'll draw one right here to service these 3 service locations here, and I'll draw one right in the middle of this backbone. I know you wouldn't normally splice into your backbone. You would usually have laterals at that point, but I'll just show you how we would represent that in VETRO after we run the build. And so I'll hit done. And so now we're going to draw an FAT that will service these other service locations in the south here. And I want this FAT to contain a splitter, and we're going to make this a 1x4. And I'll draw this in down here. Great, and save. And if at any point I need to, I can move this to reflect how it really needs to go, not in the road, but where the pole is next to the road. And now I'll draw in some laterals to connect the FAT in the cabinet that we just drew. So grab these laterals, and we can make these 12 count. And I can use this feature to auto-save VETRO parts when I'm drawing cables as well. So if I were to draw my lateral and then draw it to the cabinet and click one more time to finalize, it will finalize that entire cable. And I don't need to start from scratch with inputting the attributes again. And so now I've drawn my two laterals. And so now we're going to represent drops in a couple of different ways. We're not going to yet draw drops to these customers in the south, but these customers to the east, we will draw in some drops, and we can show you how we create equipment attachments using the quick connect method and automate the drawing of those drops. And that's some review from the circuit discussion, but I'm going to draw these drops in here, and I'll use that autosave feature again. So we'll bring it out here and click again, finalize, click to finalize, and then we'll run this along here, assuming it's on the same pole, and then done. And so now I'm going to, let's see, jump into this FAT here, and I'm going to show an example of how we would cascade splitters in this FAT. So I'm going to add 3 splitters. First, a 1x4, and we will take 2 of our strands to the south, and then we will use 2 of the ports from that splitter to cascade these other 1x2 splitters to service these cabinets, or the cabinet and the FAT. So I'll show you what all of this looks like in a moment and how we will represent this. So splitter, and we'll make this a 1x2 and save. And then we want to look at adding a patch panel to our CO here in the north. And so I'll select that attach equipment, make it a patch panel, and we'll say that it is a 24 ports patch panel and save. And then just to show how we model splice closure splicing, we're going to just add a handhole with a splice closure just to the middle of this span here. So we'll add a splice closure to the handhole, click once to draw, and save. Great. So if you recall from the draw, validate, build session that we did, that was the first webinar. If you need a review on what that is, I recommend going back and checking that out. So we'll run the build. And so now we have automated some of the splicing through all of these points and made them available. So now we can jump in and begin to configure our equipment. So the first point I want to focus on is this FAT right here. So if I open the splice diagram, we see our backbone to the north lit up as blue here. This is where we want to grab the input to that first splitter that we created. That's the 4-port, the 1x4. So then we have this lateral going to the south, and we want to bring a couple of strands into this splitter. So I clicked on that strand and I click and drag, and now we have port number 1, which I can connect, and I can click and drag this cut strand, and port number 1 is no longer available, so I'll jump to 2. And so now we've added a couple of connections to that splitter. We can now jump into the Show Equipment Connections menu and see how this is modeled here. So these are the connections that I just established. So the input is that 11th fiber of the backbone going to the north, and then going out over ports 1 and 2, we have strands 11 and 12 of the south-going lateral. Now from here, I can select port 3 and continue to attach cables that are at this point, but I can also attach the input port 1X of the other available splitters. And so in this way, I have now attached these 2 splitters to this first 1x4 splitter. So if I jump over to these, I have 2 available ports, and we're splitting that signal even more. And so now I can grab the lateral. And so for this one, we'll grab the lateral that's running to the east, and we'll grab fiber 1, sure. And we'll grab, going to the east again, fiber 2, sure. And then this one here, we want to grab our lateral that's going to the south, 1570, fiber 1, sure. And 1570 to the south, fiber 2, and connect. And we'll be looking at how that's modeled in just a moment. So just keep that in mind, that we have nested these splitters, and 2 of the splitters one of the splitters has 2 ports with 2 strands running south, and the other has 2 ports with 2 strands that are running to the east. So now we'll have a look at our patch panel here in the north, and jumping into here, we'll open this splice diagram, and we have our backbone and our patch panel. And so I can select any of these, or multi-select by holding Shift and right-click and attach the patch panel, or I can select entire buffers at a time and right-click and attach. So now I have one-to-one. Fiber 1 is going to port 1, Fiber 2 to port 2, and so on. The next thing that we want to look at is these cabinet and handhold that I added here is add-ons, just to show you some of the additional modeling, kind of the one-to-one for the splice closures. So these are all represented as pass-throughs. So I'll just cut these first 2 buffers and attach the splice closure to all of these. And now if I just shift-click both sides and splice all of these strands are now passing through a splice closure. And we'll see how that's also modeled later on in the circuit reports and the splice reports. Looking at this cabinet here, we looked at the example of the patch panel for the CO. If you have patch panels that you're using in a midspan, they appear a little bit differently. So here we need to, I guess I don't have patch panels, but it would be just like with the splice closures. So you would attach the input side first and then splice them together that way. Okay, so moving on, we now want to look at one of these cabinets here. So over here, we're interested in modeling one of these cabinet types that we see that comes up a lot, where we have a splitter that runs directly into a patch panel. So we're going to grab one of the strands that's coming in from the west, and we'll run that into our patch panel here. So we'll select the cable, and this lateral from the west, we have all of the fibers of that cable that are currently available. I'll go with fiber 1. And so here's the input. And now we can nest the ports of the patch panel from here. So if I select port 1, equipment, patch panel, port 1, and then I'll just click through the rest of these to establish all of the ports of that patch panel. And then if we jump over to our patch panel, the output, we can now select the available drops that we see represented here. So I'm now grabbing all of the drops to those service locations through the ports of that patch panel. All right, so I just want to make sure that I have grabbed everything that I need so far, and I think I do. And so now we can start to use the Fiber Manager trace to look at how the equipment is represented, all of the configuration that we just did, and hopefully it will all sort of come together. So we'll select the Fiber Manager tool here on the left. And the first thing that we do in Fiber Manager is establish our workspace. So our A location is our CO to the north, and we see the address is automatically populated there from the attributes of that CO. And then we'll make our Z location one of these service locations down here to the south. Now, what we see on the left, just as a quick review of Fiber Manager, is all of those points along the way and all of the cables that are joining them. And then we see that same information represented from left to right in a horizontal fashion here. And anywhere that we see a black circle, this represents an equipment connection. So here we have that patch panel. We're connecting to port 11 with fiber 11 of this first backbone. And then we proceed with fiber 11 to that handhold when we get to the splice closure. And then we continue on to fiber 11. When we get to this FAT and take a right, this is where we are hitting our nested splitters. So they're represented in this way. First, we're coming out of port 3 of that first splitter, and then we're coming out of port 2 of the second splitter. And then finally, in this cabinet, we are coming into our splitter, going out of port 2, and then running through port 2 of the patch panel. So we have a valid pathway from the CO all the way to our service location. So now if I check that box, and I can convert this into a circuit using this edit menu right here. So I'll save our circuit. We see the lightning bolt icon, the blue background, and we'll have a look at the circuit report in just a moment. But first we want to reestablish our workspace here, and we're going to reserve some pathways. Okay, so now we have a couple of pathways that are running south here. So I'll grab just 2 of those for now, and I'm going to just set them aside as reserved. So now using the Quick Connect tool, and again, I know this is a review of circuits, and we've talked a little bit about Quick Connect, but the interesting or important step here for today's discussion is when we use the Quick Connect tool. And in this first step, it will ask us if we want to attach any equipment to that point. If there's already equipment attached, it will detect that equipment, or we can add new equipment using this option here. I'll go with the FTP that's already attached, and next. And then it automates the creation of a drop to the nearest network point with a valid reserved pathway, which we just set aside. And then next, and we'll save. And then in the final step, it will give us the option of those reserved pathways to choose from. So I'll grab that second one there, and now we'll save. Now, the last thing that I want to look at here is how we will represent loopbacks. And I might have created a little bit of a complicated scenario for myself, but essentially what we want to do is show a circuit pathway that goes from the CO to this FAT in the middle that will run east. And when it gets to this cabinet, it will run west again as a backfeed over this lateral, and then go south to our service location. So first we need to establish a drop to one of these service locations. We'll say this one here, and give it a fiber capacity of 1. Great. And then we'll jump into this cabinet and add an additional splitter here. So this splitter, I will just make a 1x2, and we'll call it good. And so now if I jump into this cabinet, into the splice diagram, the first thing that we want to think about for this lateral that's running west is what will be our input strand for that. So let's say our input strand will be fiber 6. This is the upstream side. And then the downstream feed will be fiber 7. And so I'm connecting to port 1 of that splitter. So here we have this loopback that will occur at that cabinet. So before we jump into Fiber Manager, we want to just have a quick look here at the FAT here. So we just want to make sure that we've left an available fiber. So we have our backbone to the north, and then our lateral to the east. And our input side was 6. So I'm going to grab, say, strand 4 and bring that into 6. And then when that fiber pathway comes back downstream and it backfeeds over this cable, we then want that to splice into this lateral running to the south. And so that was 7. So I use 7 here. And so I'll bring this to fiber 3. Great. And so fiber 3 on our lateral running south. So I think I have set myself up now to complete this pathway. So we'll use the Fiber Manager tool to go from A to Z, our service location. And we're going to click again to add a waypoint. So our waypoint is going to be this cabinet here. So working backwards, we have this drop, which is not yet connected. And I'm pretty sure I hit 3 there. Okay, so by connecting the drop at the service location, we have now created a complete pathway. So we can see as I highlight on the left, these different points, they will display their label on the right. So we go from the handhole to our FAT, to our cabinet, back to our FAT, down to the second to last FAT, to the service location. And then that is represented here, of course. And these are the strands that are involved in that. And here is the splitter where we're doing the backfeeding. So I can now grab this pathway and convert this to a circuit. I'll save that. Okay, so now we want to look at some of the representations of equipment in our reporting. So if I were to jump into this FAT right here, where I have connected some of these service locations. I have not used a splitter here, so I'll use this FAT where I have used splitters. And I open the attributes for the FAT. I can now jump into the splice reports for this network point. So just a quick reminder, the splice report is a PDF output of everything that's going on with this point, all cables coming and going from that point. And we talk about that a lot more in the reports webinar, but just focusing in on the splitters that we have represented here, I'll jump right to cable C and have a look at that table because it's the upstream cable. So cable C is coming from the north. It's our backbone, which is a 24 count. And fibers 1 through 3 of that backbone are cut. Fiber 4 connects to fiber 6 of cable A, which is this lateral, and forms this circuit running to the south. Fibers 5 through 10 are cut. They have a shared range. And then when we look at fiber 11, this is the input to our splitter, the 3980. So when we go out of ports 1 and 2, we're connecting to cable B, which is our lateral to the south, fibers 11 and 12, one of which is part of this circuit. And then if we look at the final page of the splice report, we see an equipment connections table. So the best way to look at this is it's centered around these splitters in the middle. So the input to that splitter is fiber 11 from that backbone. We go out over ports 1, 2, 3, and 4. If we look at the example of port 3, we're connecting to 1X, the input for this splitter 3990. And then 3990 is here, and we're going out over ports 1 and 2 to fibers 1 and 2 of this lateral. So a very organized, easy way to visualize this information. We want to look at some of our circuits that we now have passing through this point that we've just established. So we'll have a look at 18 here, for example, and I'll generate the circuit report. So this is a PDF output of everything that is going on with this circuit from start to finish. This one is loaded with information because this is the loopback. So we're starting out at the CO, and we see our patch panel is represented here, port 4, and we're connecting to our backbone, fiber 4. And as we go through, we see when we get to this hand hole, we're passing through the splice closure, and that's represented here. When we get to that cabinet, we're connected to this splitter, and we're going out over port 1. And then we backfeed to this FAT, through this FAT, and finally we end up at our service location. And then in the second page, we have a map. So that's a quick highlight of the ins and outs of equipment attachments, how they're represented. The next part that we'll be getting into, and Alex will be showing you this and we'll be talking about it in the slides, is the material for network points, the material assignments for cables or backbones, and you can also, if you jump into any network point that contains equipment, you can also assign material directly to the equipment. So I'm going to pause my screen and jump back over to the slideshow. All right, so moving on, we're going to look at Material Manager and how it gives rise to the bill of materials. So the Material Manager is a menu in the user dashboard. And within Material Manager, you create material templates on a per feature basis. So once you've created those templates, and this is kind of the sequence or the workflow that you'll need to go through. Once you've created those templates, you'll then have material templates available to assign to your network cables, to your network points, to your equipment, or to your non-network features. And then once you've done those assignments, you can begin to generate the bill of materials. So looking at this a little bit closer, the Material Manager You can come in here and view templates that are already created, or you can create your own. You can create vendors, manufacturers, part numbers, capture labor costs and unit costs, and you can represent this on a per link basis or a per unit basis. We do have a CSV template available for bulk import of these features. And Alex will be talking about that a little bit more. So once you've created those, you can jump into any of those features, and if there is a template available, you can then assign that template directly to that feature. There's an ellipses menu there within the materials, and there's kind of two categories of options: update single feature or update whole plan. And this allows you to push updates to these materials, to these material templates that are assigned after you have made changes to the template. So once you lock a material assignment in for a network feature, future changes to the template are not reflected or pushed retroactively. And we designed it this way so that you could capture legacy costing. But if you want to, you can come in here and push those updates for a single feature or across all instances of that feature in a plan. And then when you're doing the assignment in the first place, you can apply your template to this one feature, or you can apply the template across the entire plan or across the entire project. And then there is a material validation tool that gives you sort of a check. It will list out all network features that do not yet have a material assignment. So this is a helpful check tool to make sure that you've checked off all of the items in your design. And then finally, you can jump to the dashboard and generate a bill of materials, which is an itemized cost summary of all of the network features that have material templates assigned. Any line geometric type in VETRO, like a cable or a duct or a strand, these rates are calculated as per length or on a per unit basis. So if you've drawn 4 laterals and indicated that they'll be per unit, then you would see that costing reflected. Or if you did it as a per foot or per meter costing, then the calculation would automatically be done against that rate to give you your subtotal for that template. And then you see subtotals for the categories and then a grand total. So with that, we are going to jump into the material assignment and bill of materials demo. I'm going to stop sharing my screen, and Alex is going to join us to give a demo on that.
Good morning. So I've shared my screen here. You should all be seeing this now. We're going to go over all of the topics that Stephen just mentioned here. We'll start off with a new plan that we have heading to the east of where Stephen has been working throughout this demo. And we'll go over some of the basics of actually setting up your materials. Now, when you get into your instance, assuming you have a fresh instance or you haven't worked with your materials yet, the first thing that you're going to want to do is go into your username menu, choose the dashboard, and then navigate over to your material manager. Now, when you're getting started with this, the best thing to do initially is to add your new manufacturers and brands. You can add those at the bottom here and fill in any information that you might like to keep. Once you've done that, you'll want to do similar with your vendors and suppliers, and then you'll actually want to get into your templates. Now, the main aspect of this will be the templates, since that is what you're actually going to be assigning to your features. And when you're doing this, you'll see that there is a list of all of the available features that can actually contain materials. We'll take a look at our splice closure in here. There is a template that we've already established, but we're going to go ahead and actually create a new one. And so with this new template, we can provide a name. I'm going to put in some fake names and vendors and whatnot in here. We'll go ahead and just choose some things and put in some part numbers. And this is also going to allow us to add our unit cost and our labor cost. Now, keep in mind the unit and labor costs are going to vary depending on what you have your unit set to. So if you're working in Canadian dollars, this will be CAD versus USD. And those can be changed from your settings. We'll go ahead and say that these cost us $100 to purchase and $15 to install. And we can also provide some notes and other information. Now, once we've added that template, we'll see it in our list here. And this is actually ready for us to assign to our materials now. So if we save our settings and we go back to the map here, in the toolbox, we have the option to actually validate our network, but we also have the ability to validate our materials. Now, what this is going to do is actually flag any materials within our instance or within our selected plan that are missing material assignments. So it's going to help administrators or managers find where in their network somebody may not have assigned something. Of course, if you're running a bill of materials report, you do want to be sure that all of your materials have been assigned correctly and that everything is actually fully fleshed out. So when we ran this validation, you'll see here that my splice closure does not actually have a material assigned to it yet. And if I click on that, it's going to navigate me to that location on the map, as well as pull open the attributes for that feature. If we open up the material section, you'll now see that we have some existing templates to choose from. And we'll choose our new one right here. So this is going to allow us to sign it. You'll see all of our values get filled in, and we can save. Now, if we wanted to do this on an existing feature, we can select that feature, go to the Material tab, and just switch this over to our new template. As Stephen mentioned, we can update these in bulk or feature by feature. If we are looking to update a template, let's say the price has gone up, we can go back to our manager, go into the templates, and update some values. So we'll just double both of these. And once we've done so, we can then go back to the Material tab and assign it. You'll see here that by default, these are not applied. The reason the updates are not applied here is because we want to ensure that you can keep your legacy costs in here should you choose to. But if you are inclined to update these for, say, a potential design, you can click on this ellipsis here and choose to do it just for this feature. And you'll see that get applied once I've clicked. You can also do it for your entire plan. And this will actually take any splice closure that has my FOSC 450 template here, and it will actually update it for all of them. So if I do that right now, and then I go look at my other splice closure, you'll see here that this one now has those updated values as well. Alternatively, if we have placed, let's say, all of our splice closures and maybe we haven't assigned materials to them, but we know for a fact that they are all going to use the same template, we can come back into the ellipsis and choose to apply that to our plan or our project. And this will say any splice closure in this plan or any splice closure in this project should now use this template here. So if you have existing materials, be careful doing this because this one will actually overwrite them. But it will also be extremely useful if you're trying to assign these materials to a new plan. The other thing we could do with materials is actually assign these to our cables, to our slack loops, to our poles, as well as equipment. So if I create a new point here, we'll call it a fiber access terminal. And we have a splitter in here, such as a 1x4, such as Stephen was adding earlier. We can actually go ahead and choose a material for both the FAT and the splitter. So for the FAT, we can come into here and choose our material. And for the splitter, same process. We just open up the material, choose our template, and we'll assign our 1x4 and save. And so all of this will come out into the BOM, which we can access from our settings up here. Once again, we'll go into the dashboard, except this time we'll navigate into the reports section, open up the bill of materials, choose our project and plan, and then generate the report. We'll see this report come out here. Keep in mind that this one is not very fleshed out. This is just the stuff that we've assigned here with the addition of one cable. But the format here will be your project name, your plan name, your date. You'll get your fiber cables, all of the values filled out in those, as well as your network points and equipment that you've assigned. Now I have an example here that is more fleshed out that we'll show you. Essentially, the different types of materials you can assign will include your fiber cables, whether you do that per meter, per foot, or per cable. It will include your network points. It will include your equipment such as splitters and patch panels. It will include ducts if you're working with underground areas. Non-network points will cover your slack loops. In particular, that's going to cover things like snowshoes and such. And your hardware under here is actually going to cover any materials that you've assigned to your poles, such as anchors, down guys, J-hooks, brackets, etc. And within the actual table here, you're going to get your part numbers, your template names, either your quantity or your length, your unit costs, the extended values of those, your labor costs, extended values of those, some subtotals, and then your actual final total at the bottom here. Now, one last thing that I wanted to cover here was the ability to actually assign your materials to your poles, since these are slightly different than assigning to your standard equipment or point. So when you're doing this, we'll go ahead and place a new point, and we'll call it a pole. And when we're doing this, you'll see that there is actually a new option up here at the top. This will only be available for poles, but it's going to allow you to create hardware on top of that pole. If you open that up and choose Add Hardware, you'll have a list of available pieces. We'll go ahead and roll with an anchor for this. And then you'll actually be able to choose from your templates that you've created in the same way that you did with the network points. We can say there's an anchor screw type here. We'll save that. And we can actually say maybe there are 3 of them on this pole, as well as a riser and maybe a down guy. And so now what we said here is essentially we want to see 3 anchor screws in the BOM. We want to see 1 riser guard in the BOM. We want to see 1 down guy in the BOM. And it's just going to add that for you, but it's going to help you keep track of that without affecting your actual splicing and circuitry. And with that, Stephen, I believe I will pass it back to you.
Okay, great. Thanks a lot, Alex, for that demonstration. So I'm just going to open up my screen again here. So that concludes all of the regularly scheduled content for today. Be on the lookout for invites to future user enablement sessions. The next one is scheduled for the 3rd of April. We have some more topics in the pipeline. If there's anything that you would like to see represented in these sessions, please feel free to reach out and communicate that with us. And just a reminder to contact our technical support team Monday through Friday, 8 a.m. to 5 p.m. Eastern Time via email or phone if you have questions about anything. And for general information, including sales inquiries, feel free to contact our sales team. So from everyone here at VETRO FiberMap, thank you all for joining. We look forward to hearing from you and contributing and continuing to work together to make VETRO FiberMap the best fiber design and management tool available. Thanks again.